So what's your name? Ravi. Only Ravi or? Very good. You seem to be very sincere. Very good. Chalo. So let us start. Online students. So I hope that you are able to hear me. Let me just check how many have joined. Okay. Okay. So as usual, not too many. Um, so Nidhi, please take the attendance for the online students.
Okay, sir.
Just keep a screenshot, that will be sufficient. So I will go back to So today, students, today is your last class, last formal class for um, this course, computer networks. So today we are going to cover the topic, the protocol HTTP, but we will do it at a very high level, very sketchy introduction of HTTP. If we have to go too much deep into it, first of all, it is not required, and secondly, it's going to be too exhaustive. So from the viewpoint of the purpose of this course at the UG level, I'm going to cover whatever is required for you to understand of HTTP at this level. So HTTP is a protocol which I am sure almost anybody who has ever used the internet has encountered. So what do you do when you type the URL on your browser window? You type http:// like that. So what is it? It is basically you are instructing the web browser to use the HTTP protocol for taking the next steps for loading the website for which you are giving the URL. So sometimes you must have noticed that sometimes on the web browser we may use some other protocols also. So there is another protocol HTTPS, which is the secured HTTP. Like this, sometimes many web browsers they support the FTP protocol. So instead of typing http:// it will be FTP colon blah blah blah. So that means we are instructing the web browser to follow the HTTP protocol to access the contents of the website for which we are giving the URL. Okay? You are able to hear me clearly? Okay, very good. So what is this protocol? We'll understand at a high level. What is the full form of HTTP? Hypertext Transfer Protocol. Hyper H text T transfer T protocol P. HTTP, Hypertext Transfer Protocol. So this protocol has a special purpose. It has the purpose of retrieving objects from the remote website for display on the client's site. Again, the client server based model, which you are very much familiar by now. So it is for retrieving the contents of a remote website, a remote web server. Okay. So it will retrieve the web pages using the client server model. Now for HTTP, two ports are required. For any client server, you need two ports. One is what? the well-known port runs at what? The server end, which is 80 for HTTP. The server will use port number 80. For client, it is the ephemeral port as usual, unless there are some deviations, right? So we also looked at some deviations for some protocols which use some temporary, not instead of temporary port number, instead of ephemeral port. For the client side also they use the well-known port, but HTTP follows the usual way. It will, for the client, it will assign a temporary port number, the ephemeral port number, and for server it is always port 80. Now HTTP is an application layer protocol. It has to take the services of the transport layer. For transport layer it uses TCP. Now the beauty of TCP is that it is already reliable, connection oriented. So consequently HTTP is safe. HTTP is getting the services of a reliable, connection oriented protocol. So HTTP is safe. So that way HTTP gets a level of reliability due to the use of TCP at the transport layer. Now for any transaction between this between this client and the server, first you need to establish a connection between them. Connection establishment, then data transfer, and then the connection has to be terminated. Usual model. So let us try to understand that how it is done in HTTP. In HTTP, for establishing the connection, there are two main models. One is called non-persistent, the other one is called persistent. This non-persistent connection basically uses only one TCP connection for every request and response pair. So one TCP connection for request response, another request, another connection, and so on. But then let us look at the three main steps that are used in the non-persistent connection. Number one, the client will first open this connection and send the request. Client opens TCP connection, transport layer, TCP connection, sends a request. Server, to this request, if the server is okay, it will send a response back and then it will close the connection. So client sends a request, server responds with a response, and then it will close in non-persistent. However, as we will see shortly, persistent doesn't close the connection at the server end after sending the data, but non-persistent does. Client requests, server responds, it closes the connection. The client reads the data until it encounters some marker, some flag, the end of file marker. Okay, and then the client will close the connection also. Understood? TCP connection, response. So the client, whatever it has requested, has already come back to the client. Server has already closed, and then the client basically accepts that, and then it also closes. So this is the full cycle, 1, 2, and 3 steps in the non-persistent connection. However, as you can understand that in non-persistent, if you every time if the server closes for every small request, it's going to be heavy, right? So there will be too much of overhead on the server. So the server, because of this, the server needs n+1 different buffers each time the connection is opened. So because of this, so there is this non-persistent connection HTTP versions 1.1 and before, it used these non-persistent connections. So this is the gist of non-persistent connection and the overall steps that are involved in the client server model of non-persistent connection. Persistent connection, unlike what the server in the non-persistent case does, in persistent the server will not close the connection and will keep it open for more client requests for sending a response. Then the server will close the connection at the request of a client. So here it is important. The client has to specifically request the server to close the connection. Otherwise, it will leave it open. It means the server will leave it open. Or the server can also time out and it can close the connection. So obviously a timer is maintained at the server. After the TTL duration, it is also going to time out and automatically close unless it receives a specific explicit request from the client. The sender usually sends the length of the data with each response. So there are some occasions when the sender doesn't know the length of the data, because it can be a case where the web pages are not static, dynamically created, recreated and so on. And in these cases the server informs the client that the length is not known, and then it closes the connection after sending the data, so the client knows that the end of the data has been reached, because the server knows what is the end when it has reached the end of the web page. So once it has reached the end in dynamic web pages, the server can initiate that connection. So in the persistent case, the time and the resources are basically maintained, it is saved, and only one set of buffers and variables will need to be set for this persistent connection. In the case of non-persistent, how many buffers? n+1 buffers. So this HTTP version 1.1 and beyond basically started this persistent, it should be persistent, basically persistent connections. Now this request and response message, request from the client, response from the server, it has a certain specific format, the message format. So the left hand side picture that you see is for the request message format, and the right hand side that you see is for the response from the server, the message format for it. So what are the main components of it? For the request message, there is the method, URL, version. So that's the request line. Then there are a few header lines, few blank, and finally it comes to the body. So this is the the body of the message that is sent from the client to the server. Same goes, very similar, but here actually, as you can see, not just the version but the status code about whether it is successful or not, the response, the server is able to successfully it is able to execute the request of the client or not. So those things are basically returned. So this method, so the first in this thing, as you can see over here, there is this method. Okay, what are these different types of methods that are supported? In HTTP, these are the main methods that are supported for the request messages. What are these methods? Number one, GET. What is the action? It requests a document from the server. So you can have a GET message set here, over here. It is GET. So for if a GET message is set, then this method it will be marked as GET, and that particular message for GET will be interpreted by the server as for retrieving the document from it. Then similarly, there is the head which requests the information about a document, but not actually the document itself, kind of the metadata about the document. Then like GET, there is a put, but there is a difference. The put basically sends a document from the client to the server. Post sends some information from the client to the server. Trace echoes the incoming request. Delete removes the web page. And like this, actually, these other options are there. Now, what are the header names for the request message? So, it could be user agent, accept car set, and so on. So, basically, each of these header lines will send additional information from the client to the server. Okay. For example, the client can request that the document be sent in a particular format. We'll have the header name, a colon, a space, and a header value. And this value field will define the values that are associated with each header name. So what are these different types of headers? User agent, which is for identifying the client program. Accept, it shows the media format the client can accept. Accept car set, shows the character set the client can handle. Accept encoding, shows the encoding scheme the client can handle, and so on and so forth. So the request has been sent from the client to the server. The server now has to respond back with the whatever has been requested by the client based on whether it is GET or PUT or whatever it is. Now what is the response? The response message will consist of the status line, the header lines, blank line, and the body. So the first line is called the status line. Here there are three fields separated by spaces and terminated by a carriage return and line field. The first field basically defines the version of HTTP. So whether it is HTTP 1.1 and so on. The status code field will define the status of the request. It consists of 3 digits, whereas the codes in the 100 range are only informational. The codes in the 200 range will indicate a successful request. The codes in the 300 range will redirect the client to another URL, and the codes in the 400 range will indicate an error at the client side. And the codes in the 500 range will indicate an error at the server side. So these things basically, it's not like, you have to cram your head and you have to remember. But basically when people, do programming using HTTP, etc., automatically few of them, they tend to remember. Now, each header line will send additional information from the server to the client because it's a response message. For example, the sender can send extra information about the document. Each header line has a header name, a colon, a space, and the header value. And these are the different headers that are supported in the response message. So for example, the header date shows the current date. Upgrade specifies the preferred communication protocol. Server gives information about the server. Set cookie, basically the server asks the client to save a cookie. And like this, basically the other different header types are given over here. So let us take one of the most important messages, the GET message. Sent from whom to whom? Client to the server. So here is the client, here is the server. Now this client basically sends the message 1. User bin image 1, HTTP 1. So what does it mean? So the client wants to get this object image1, which is located somewhere here, using the protocol HTTP 1.1. And it also specifies that it can accept only the GIF and the JPEG formats. Now the server will send a response back. So what does it do? It says the status message, it is the OK means this is the status, right? 200 basically is what? 200 basically says that the response has been successful, right? You remember sometimes you get 400, some, when you are not, when the site is not accessible, you get a 400, 404 or 401 messages. So those are basically when it is not successful. And then a few other things, etc. Name of the server, content encoding, content length, etc. And the body of the document that is basically requested by the client. This is the get method. Likewise, you have the put method. So just very similar kind of thing. And then you have the proxy server. So we need to understand this proxy server. On one end you have the client, on the other end you have the server. But in between, sometimes in some network configurations, for example, the way we have in our IIT Kharagpur network, there are certain proxy servers that are sitting in between. Now, these proxy servers will have support for HTTP. So, these proxy servers do what? They are like proxies of the actual server, which are sitting in between the actual client and the actual server. So, this proxy server, it will keep a cache of the different requests that are going between the client and the server. Locally, it will keep a cache. Now, this client sends a request to the the client basically sends a request to the proxy server. First, this proxy server will check its cache because it has been keeping copies of everything that was flowing through it. If it can find, well and good, it doesn't have to forward the request to the remote server. It can service from its own cache. So the incoming responses are sent to the proxy server and stored for future requests from other clients. The proxy server, by doing these steps, number 2 and number 3, it is trying to help the original server by reducing the load that that original server is going to encounter. So it decreases the traffic and it improves the overall latency. Latency in what sense? End to end. So instead of the message having a propagation delay from the client end to the actual server end, it is stopping somewhere in between and sending a faster response. So basically that response time reduces. However, to use the proxy server, the client must be configured to access the proxy instead of the target server. So the client basically has to be configured in such a way that it should have access to that proxy server. So when it receives a request from a client, okay, the proxy server, for which it has a response, it acts as a server and sends the response to the client. When it receives a request from a client for which it does not have a response, it first acts as the client and sends the request to the target server. Try to understand. So you have on the left hand side you have the client, on the extreme right you have the server, in between you have the proxy server. So the client sends a request which is stopped by the proxy server. It looks whether it has in its cache the response that the client is looking for. If it has, it is going to give it back to the client. If it does not have, then the proxy server will become the client and it will forward the request to the actual server. So then the proxy server client, actual server, and there will be the client server interaction between them. So look at this local area network configuration over here. So here we have a proxy server, okay, and through this proxy server, basically, so whether it is true or not, basically it depends. Like sometimes the proxy server can be configured as a gateway also. So in this case, it is not shown that way. So you have a separate gateway, you have a separate proxy, and whatever be it. So basically, this is your local area network. This is your wide area network, and then so the proxy server is going to basically intercept any request that is going to go outside the local area network like this, and it's going to respond back. If it doesn't have the data, then it will become the client itself. Okay, it will become the client itself, and then to the remote server, any of these web servers, it's going to send the request forward. So with this, basically, we come to an end of this topic, HTTP. We are on time also, which is good. So first, so before we close this, on HTTP, any of the students has any questions? Let me once again check who all are online. Okay. So I see that quite a few have joined after we started, and okay. So Nidhi, you can now stop the recording because we'll have simple interactions. Huh?